Alright, so the question is, use orbital notation, Lewis dot formulas, and oxidation numbers excuse me, to show how a compound of aluminum and selenium would form. So we'll start with orbital notation. So aluminum is in the third primary level, so we're going to have to fill up the first and second primary levels. And in the third primary level, we've got an s orbital and the p orbitals before we get to aluminum. So I have to have 3s and 3p there. So that's the orbital notation for aluminum. And then we have selenium. And selenium is in the fourth primary level. So before I can get to the fourth primary level, I've got to completely fill the third primary level. And now we start the fourth level. And in the fourth level, we introduce the D sublevel, which drops back to the third level. So this is the D sublevel region here, and that's before we can get to selenium over here. So 3D with 5 orbitals. 4p, and I need 4 electrons in this p sublevel region. So I need 4 more electrons before I get to the final version of the orbital notation. Okay, excuse me. All right, now aluminum is a metal. It tends to lose electrons. What's so funny? Okay, just curious. I like to laugh too. All right. Yeah. All right, so aluminum, being a metal, it tends to lose electrons, but you can also look at it like this. To have a full valence level, you've got to have 8 electrons. It'd be easier to get rid of 3 than gain 5, 3 being a smaller number. That make sense? All right, so I can take this electron and put it right there. I could take this electron and put it right there. And so we're getting rid of those 2 electrons, but I've got another electron to get rid of in order to be left with a full valence level of 8. So I need another selenium. Well, I would go through and just fill up the valence level, but I tried to do that one time, and everybody, not everybody, some people that weren't paying attention were kind of taken aback by that, and I had to go back and fill them up anyway. So I guess I'll do it anyway. I know I'm being sarcastic. It's okay. All right. Okay, so I can remove this electron now down here. Y'all are talking again, not paying attention again. All right, so aluminum has a valence level now remaining. It's full, excuse me. But I need another electron for selenium. So I need another aluminum. I hear talking over there that doesn't have anything to do with this. Imagine if I called you by name and it ended up on the video that I put on the website, and your mom or dad listened to it, I wonder what they would think.
They probably wouldn't. My parents listen to it, no, it's online. They don't know how to get on the internet. My parents have noticed I go across the street from videos. My parents go down
All right, so this electron can go right there. All right, that one's going away. That takes care of both seleniums. They have a full valence level. But aluminum now needs to get rid of two more. I better not hear anybody say, "What are you doing?" What? What? If anybody is listening in on this video that doesn't have any idea what goes on in this class, we are just being playful here.
Hey.
Hey. Hey.
We're just being playful, guys.
Mr. Hunter?
Can I finish this first?
Why did you put smoke on the floor?
He's got to use his white out.
Satisfied?
Yes, thank you.
Okay. I'm glad you're satisfied. There you go.
I thought that was a Sigma bond or something.
No. It's just a stray mark. All right. So I can put those last two electrons here. One of them right there. One of them, and that one goes away, and put that one down there. And now every atom in this structure is reasonably happy. But since I got rid of 3 electrons, I need a 3+ charge here. Since I gained 2 electrons on the selenium, I need 2 minus. And each selenium is the same way. Okay? All right, so that would, now, I guess you could also redraw everything to show it at the end of it, but that's a reasonable way of showing it, if you actually marked out the electrons or erased them and show where they went to. Okay? So that would be orbital notation. What number are we on again? 60? All right, we need to show Lewis dot formulas. Aluminum has how many dots?
3.
Selenium has how many?
6. Mr. Hunter? The orbital rotation thing, we have to write all that out on the test if that was the question.
Yeah.
Yes. To get all the credit.
Huh? What?
That was a normal question.
Okay. All right. Yes, you'd have to. It depends on the question, but yes, essentially.
Well, it doesn't mean you should talk about how stupid it was.
I'm sorry. I'm being playful. I apologize. Bailey.
Can you see that outside? But it was a normal question.
You're right. I'm sorry. Huh?
Are you really getting a stress ball?
What?
Was that a stress ball that you got out of a... If so, can I borrow one?
Tell me, please throw it.
I thought it was a stress ball. I have some
Are
stress
those tiny little planet Earths?
Yes, there's tiny little planet Earths.
So you can destroy the world with planet
Here's the one.
Whole world in my.
Just leave that on the
Put that on YouTube. I love it.
I'm trying to relieve the stress here for everybody. Huh? What now? What do you think?
Yeah, extremely. Every now and then.
And mostly because of Marissa, but.
Oh, Marissa. He's got crack on cigars.
See if she was paying attention, she'd know. All right, so we got 2 aluminums with 3+ charges. All right.
Your stress balls were an earth, and I was like, really destroying the world.
They said,
And then we got
this class is stressful, and they said,
seleniums now have 8 electrons. And we added how many electrons on the seleniums? So what kind of charge we put on there?
-2.
So we got 3 of them. And then to put together a chemical formula for that, we're going to have 2 aluminum with 3 plus charges, 3 seleniums with 2 negative charges, and we get aluminum sub 2, selenium sub 3, like that. And we can check the math, where we check and make sure the charges are working out. 2 times 3 plus, 3 times 2 negative, and that equals 0. So we do have a neutral charge there. Okay, and that's what we wanted to do. All right, so that's Lewis dots. Okay, and let's see, oxidation numbers. Okay, so oxidation numbers come from the periodic table with oxidation numbers. Right there,
you basically already did it, did you not?
pretty much.
Yeah.
So for that, we go and look at aluminum as a 3 plus charge. Okay. There's aluminum with a 3 plus charge. And we look at selenium. Selenium's got a bunch of choices, 1, 2, 3 choices. But we have to have a neutral compound. So we have to choose a choice that's going to allow us to get to a 0 charge. The only one that works is the 2 negative version. Okay? One sec. Okay? So there's a selenium with a 2 negative charge. All right, to make the math work out, we do 3 plus here, plus 2 negative there. We want the whole thing to equal 0. So what we're looking for are coefficients that will make this math problem work out. 2 and 3. And so we put a 2 here and a 3 here. And yes, we pretty much end up with the same thing we ended up with over here. Okay? So we end up with Al2Se3. An oxidation number is a number assigned to an element to help make balancing the formulas easier. And that's all those are. They're assigned numbers that make balancing formulas easier. Okay? Does that make sense?
I was asking about on those, when use the box one, right? If there's much more than one reason, I have a box around it.
No, the boxes are the most common of the common. There are more oxidation numbers than appear on this periodic table right here.
So I'm saying, how do we
Okay, let me just finish. Okay, hold on. There are more oxidation numbers than appear on this table right here. So these are the most common ones. The ones in the boxes are the most common of those most common ones. Okay? So, no, you don't choose the ones in the boxes. You choose the one that fits the problem. Does that make sense? I'm about to go horse here or something. That's why I need a long weekend. Need something. Ricola, yeah.